Right, good evening. Today we are going to be looking at sampling methods. So we've already talked about the different reasons why we sample instead of looking at the entire population. So we say that it might be costly, it might take too long to sample the entire population. So it's easier instead to collect data from a sample. Now there are two methods that we use when we are sampling. The first one is probability sampling and the second one is non-probability sampling methods. Okay, now with probability sampling, what we have is that every element in the population has a known non-zero probability of selection. So nobody has a zero chance of being selected. So when somebody has, or somebody or some item has zero chance of being selected, it means it is impossible for them to be part of our population. But we're saying that in probability sampling, there is no such person or element. Everybody has a chance of being part of the sample. Now, this is different from non-probability sampling in that non-probability sampling, there isn't really a good way to estimate the probability of an element being included in the sample. So there is no objective way of evaluating how far the population parameter differs from our estimate. So if you use some of these non-probability sampling methods, and then you get an average lifespan, for example, of 25. Now that 25, you can't really make too many conclusions. Um, is it really applicable to the population? You can't really say too much. And with this non-probability sampling, you see that there's a bias that is introduced. So it might not truly represent the population of interest. So one may ask, if this is the case, if this is true about non-probability sampling methods, why do we use them? So when we talk about them, I hope you'll be able to understand why it is that we do use them when we do. Now with probability sampling methods, there are four main types that we look at. We have the simple random sampling, the stratified, the cluster, and the systematic. Now the first one is the simple random sampling method. Now this one is very simple to do. So imagine you guys are all sitting in a class and there's 100 of you. Now I need a sample of say 15. So what I will do is I will put all your names in a hat and then I will just pick 15 of you. Okay. Now what we'll notice, or what we know about simple random sampling, is that every single person or element in the sample has an equal chance of being selected. So nobody has any advantage that this person will definitely be in the sample or this person will definitely not be in the sample. So everybody has an equal chance of being selected. And then another thing is that every sample is equally likely. Now I could pick 15 names out of those 100 from the hat. I could put them back and then I say, okay, I want another sample, still 15 people. So I pick 15 people out of a hat and then I notice that this second group of 15 people is different from the first group of 15 people that I picked. Now what we mean by this point number 2 is that the chance of me picking sample number 1 compared to sample number 2 is exactly the same. So sample number 2 doesn't have an advantage, or that it is more likely to be picked compared to the other one. Okay. So what do we need when we are conducting a simple random sample or using simple random sampling? The first thing we need is the list of all population members. So if I have 100 of you in the class, you're all sitting in a venue, that's easy because you can all write your names on a hat and I can on a paper, not a hat, and then I could select your names from the hat. Okay, so we need a list. Then we need something that will induce some sort of randomness. So what I mean by that is like picking the name out of a hat, picking names out of a rotating drum, tossing a die. Now, tossing a die, what this means is I could go to, since all of you, 100 of you are sitting in a venue, what I could do is I could give each one of you a die in turn and then say roll it. So if you get an even number, I would select you to be part of my sample. And if you get an odd number when you toss the die, then I would not select you as part of my sample. Okay, so those are the ways that we can select a random sample. So we can also use a table of random numbers. So there are lots of tables that are out there. You can Google some, you'll see that there are tables that it's just a list of random numbers. So I see that I need 100, and that table just lists 100 numbers in any random order. Okay, so I would just pick, since I need 15, I would pick the first 15 numbers. You might see the first one is 97, then 3, then 5, then 16, 12, 11, until I have 15 sample elements. Could also use computer programs. They are random generating programs that are done. I think your calculator also generates random numbers, so you can also make use of that. So you just need to specify this is the sample size that I need. This is the population. So the population is 100, but out of that 100, I need 15, and then it will generate 15 random numbers for you. Then the next type of probability sampling method that we use is the stratified random sampling method. Now with stratified, what you notice is that they are groups, okay, that elements belong to. And what we know about these groups is that within the group, there are characteristics that are homogeneous. Okay, now what that means is if I wanted to, if I was doing a study on gender equality, maybe, for example, and if I asked a group of men, do you think there is gender equality in Namibia? You might find men say, yes, everybody's treated the same. But if I asked women, do you think there is gender equality in Namibia? They might say, no, this is what I've experienced, and so on. Okay, so you can see there's a separation between the groups of men and the groups of women. So it's not just restricted to gender. You might have things such as level of education, for example. Okay, so you want to ask or you want to find out something, and then you ask people whose highest level of education is primary school, you compare that to those whose highest level of education is high school, and those whose highest level of education is the university, for example. You might notice that those who only went up to grade 7 or primary school would answer in a certain way. Those that went only till high school would say they would answer in a different way. So there's like a homogeneous trait within the groups. Okay, so there are different groups within your population, and within the groups are homogeneous. So the basis for grouping or stratifying must be known. So it must be clear that we are separating these two groups based on gender, whether it's male or female, depending on what it is you're investigating. And a random sample is selected from each stratum. So stratum is the singular for stratum, based on the percentage that each subgroup represents in the underlying population. So if you're looking at level of education and you see that in your population, those that went only as high as primary school make up 20%, those that went to high school 40%, those that went or that have a bachelor's is 30%, and then those that have a postgrad are 10%. What you would do is you would stratify your population like that, and then you would pick elements, making sure that you have 20% that represent those that only went to primary school, 40% those that went to high school, and then 30% those that have at least a bachelor's degree, and then 10% those that went further than the bachelor's postgraduate, for example. Okay, now usually we do not like our number of strata to be too large, so six or less. That is what we prefer. Now the next um, probability sampling method that we use is what is known as a cluster random sampling. Okay. Now cluster random sampling is similar to the stratified random sampling, except that here we have groups just like with the stratified random sampling, except here within our groups are not homogeneous like with stratified. So remember, stratified, they are homogeneous, they behave or they react in a similar way, but in cluster, our population is clearly divided by something, but within those groups or what groups them, they are not heterogeneous. So one grouping or one characteristic you can look at, for example, if I look at students, now students may be grouped according to their year of studies. You have first years, second years, third years, fourth years. But within the first years, you have males and females. It's not just males who would all answer in the same way. Same thing with the second year, third years, and so on. So stratified, we have groups, yes, but within the groups are homogeneous. But cluster, we also have groups, but within the groups are heterogeneous. So that means you may find different types of elements within the group. They're not all the same or likely to give the same answer. Okay, another instance where we might need to use cluster random sampling is when the population is large and spread over a geographical area. So for example, the way the country is divided into the regions, so we can see that even within a region like commerce, for example, it is not homogeneous. You can't just say everyone from commerce will probably say this. That is not the case. So what we would do with this cluster random sampling is we would pick a cluster at random, and then within the cluster we then do a random sample. So let's say we have our 14 regions. What we do is we decide we're going to pick 4 regions at random to represent the country. So we might pick Commerce, we might pick Ochosonjupa, we might pick Hardap, and Irongo. So we pick those at random. Then within Commerce, we can also again randomly select elements from there. You can use simple random sampling if you have the entire sampling frame, which is the list of all the elements in the population. Okay, so here with cluster, you also have groups, but your groups are not homogeneous. With stratified, you have groups, but your groups are homogeneous. And then the next sampling method that we look at is the systematic sampling method. Now, with this systematic sampling method, what we notice is that the population is arranged in some order. Okay, so because the population is ordered, it might be easier to draw a random sample in a systematic way. Now, to select a systematic sample of n elements from a population of capital N elements, we divide the n elements in the population into n groups of k elements, and then we use the following rule. Okay, so here we have a sample whose size is capital N, and we want to choose a sample with size small n. So what we do is we will say the big N divided by small n, that will give us k. Now we round off k to the nearest integer. We randomly select the first element out of the first k elements, and then we pick every k element until we have a sample of n elements. So I have an example over here. Let's say I have a population of 700. Now out of those 700, let's say these are cars in a dealership. I have 700 of them, or a manufacturer. So I want to pick 30 of them because I'm going to examine some characteristic of the car to make a conclusion about the population. So what I do is I want 30 of them, and they're all sitting in the lot or wherever it is they're kept. So what I will do is I will first say 700 divided by 30. This will give me 23.3. Now 23.3 is not an integer, so what I do is I would round it off to the nearest integer, which is 23. Now what I do is I will then randomly select a number between 1 and 23. Now this 23 that I have over here. So I randomly select a number between 1 and 23. So I could put all the numbers 1 to 23 in a hat, pick one, or use my random number generator, and then it'll give me a number. So let's say I do that, and then I pick the number 15. So after I've picked the number 15, I will then pick every 23rd number after that. So my first number is 15, which I got from picking a number between 1 and 23. Then to get the next one after 15, I just keep adding the k value. So this is my k value over here. So I started with 15, then I'll have 38, and then I'll have 61, 84, and then I continue until I have 682. Okay, so you can see there I have my 30 elements. Okay, now let's consider some scenarios of when we would use these probability sampling methods. I keep saying random, but random and probability mean the same thing. Okay, so here we have a scenario of 500 companies that are listed by this Fortune magazine. Now, this Fortune magazine lists each and every single one of those 500 companies. Now, imagine you're an economist and you want to work out the net income of all the firms in the index. So the magazine lists all the 500 companies. So that 500 consists of the population, and you want to work out the net income of all the companies there. Okay, now going to all those 500 companies one by one is going to take you a lot of time. It's time consuming. It might be expensive driving around the country, going to this one, then that one, and so on, making appointments, coming back. It'll take you a long time. Okay, and it might be difficult or it's impossible for you to do. So what you do is you decide to sample. So again, these are reasons why we sample instead of just considering the entire population. Okay, so now this economist wants to pick 100 elements out of the 500. So we need some suggestions. How might he do this? Okay, now we've talked about before, we did the simple random method. There's also the stratified, the systematic, and the cluster. So you have those 4 options. So take a minute, think about it, and decide which one will you use. Now most people always go to simple random sampling. Yeah, let's simple random, but it might not always be the best. Now this person is an economist, and according to what we have over here, they believe that firms in the same industry group share common characteristics related to their net income. So these are the groups of the companies that we have. So if you look at companies, you can always tell what type of company it is. Is it a financial service company like, I don't know, those that deal with insurance, lending out money, and so on? Is the banking company, just like the banks that we have, Lesejo, F&B, and so on? Retailing companies that sell stuff, so Pick and Pay and so on. Transportation companies, Intercape, so on. Utilities, water, power, and so on. Diversified service companies. So this may be like cleaning companies, security service companies, and so on. Now this economist has found that companies within the same group share common characteristics related to their net income. So what that means is those in the diversified service or those that are diversified service companies, their net income is pretty much the same. Those in the banking sector, net income is basically the same. So if you were to do a simple random sample here, what you might get is you might get a large number of banking companies and financial service companies, because these form the greater part of the companies. You can see I have 100 diversified service companies, 100 commercial banking companies, 150 service companies. So it might inflate the net income that you have. That means the net income that you get, or whatever you estimate, might reflect more on the top 3 companies, the top 3 groups that are listed here, as compared to all of the groups together. So simple random sampling, you can do that, but that might not be the best. So you might also look at a systematic. Now with systematic, you have a list. Now this list was provided by the magazine. So depending on how the magazine listed the companies, it might be good. It might be a good way to go. If it listed it alphabetically, it might not be. If it listed them according to the group that they fall in, maybe that might be a better estimation. So it depends on how they are listed, because if I have them listed alphabetically, maybe it's just bank, Windhoek, bank, F&B, bank, this, and so on. so that might not be so good. So here cluster would not be good, because even though I do have groups, remember when I say that if you have groups you must think of either cluster or stratified. Now here cluster would not be the best, because even though I do have groups, within the groups the economist has said that um, the net income, or the characteristic of net income, is the same. So my groups are homogeneous. And we say that when we have groups are homogeneous, we should think of stratified random sampling, or this we would use stratified random sampling. So we arrange our um, elements by the homogeneous groups, and then we pick elements from each of the groups based on the number that you have here. So the diversified service companies, there's 100 of them, so 1/5 of the number of companies that I pick should be from the diversified. Same thing, 1/5 of the companies that I pick in my sample should come from the commercial banking, and so on. Okay, so questions like this is just to gauge your understanding. Do you know when to apply what method? Um, can you explain it? Most of the questions we get or we give on this section is not so much on explanations, it's more knowing which method to pick, but it's always good to know and understand and be able to explain what method you would pick, why you would pick that method, and why you think that method is the best. Okay, look at another, this is an exercise. Very quickly here, we have a large discount store gives its sales personnel bonuses based on their average sale amount. Since each salesperson makes hundreds of sales each month, the store manager decides to base average sales amount for each person on a random sample of the person's sales. Since records of sales are kept in books, the use of systematic sampling is appropriate or it's convenient. Suppose a salesperson has made 855 sales over the month, and management wants to choose a sample of 30 sales for estimation of the average amount of all sales. Suggest a way of doing this, but there are no problems with result due to the fact that 855 is not an integer multiple of 13. Give the first element you would choose to select, and explain how the rest of the sample is obtained. Okay, so here again is just gauging your understanding. Do you understand how systematic random sampling works? Systematic random sampling works. So here we're saying that can we still use systematic random sampling even though we want 30 elements and 855 is not an integer multiple? Well, with the 300 that with the 700, and when we wanted 30, that the previous example I did, it wasn't an integer multiple, but we were still able to do it. So the way you would do it is still, you would say 855 divided by 30, and you would get 28.5. Now you may round this 28.5 to 29, or you may round it to 28. I would round it off to 28. Then, now what you do is you select a number between 1 and 28 at random. Use the tossing of a die or picking a number out of a hat or so on, whatever method really. Then you pick every 28th number, so on. So let's say I pick a number at random, I pick number 5, and then I will say the next number is 5 plus 28, which is 33, then I add 28, which is 61, and so on until I have 30 elements. Now you could also have rounded it off to 29, but you'll notice you may pick a first number, and the 30th number is no longer inside the range of 855. So with that, I would just go back to the beginning. So sort of like a cycle. So once you get to number 855, move on to number 1, because chances are you didn't choose number 1. Otherwise, you wouldn't be outside of the population. Okay. So here's another example for you guys to think about. Then you can tell me what you think. So this one has to do with beer sales in a turban. We're told that they're cyclic over the week with large volumes during weekend nights, lower volumes during the beginning of the week, and somewhat higher volumes at midweek. Okay, so which makes sense. At the beginning of the week, people are busy. Middle of the week, they're like, I'm done with this. I'm going to the turban. Friday, that's the day. You can see they're packed. So now it says here, explain the possible problems that would arise and the conditions under which they might arise if systematic sampling were used to estimate beer sales volumes per night. So I'm sure you can think a little bit and even tell me. So you know that during the weekends sales are very high. Middle of the week they are moderate, not so high. The rest of the time, let's say on a Monday, they are pretty low. So even just thinking about it, I'm sure you could see if I was to pick systematically, I'm picking every second day. That means I pick Monday, then I pick Wednesday, then I pick Friday, and then I analyze that week. I might say, wow, my sales were pretty high just because I picked Wednesday and Friday in that, because Wednesday they're pretty high and Friday they are really high. Okay, unlike if I picked Tuesday, Thursday, and Saturday. Saturday, yeah, you might say is quite high, but Thursday and Tuesday, those you expect them to be low. So you can just think about that, and then you can also put that in your own words. So those are the kind of things we want you to think about when we give you a question like this. The next one, the makers of Taster's Choice Instant Coffee want to estimate the proportion of underfilled jars of a given size. The jars are in 14 warehouses around the country, and each warehouse contains crates of cases of jars of coffee. Suggest an appropriate sampling method and discuss it. Okay, so here, again, you could probably make a case for just about every sampling, each of the sampling methods, whether it's simple, random, stratified, cluster, so on. So here we just want you to think. Here we're making coffee, or these are the producers of coffee, and you want to underestimate the proportion of underfilled jars. So you can see these are things that do happen when you're manufacturing. The jar is not as full as it should be. So maybe they've had some complaints from customers and now they want to actually investigate, are we really underfilling our jars? Now we're told that these jars are in 14 warehouses around the country. Each warehouse contains crates of cases of jars of coffee. So you can take a minute, think about this, and then see how you would go about handling this. So there isn't really a right way, I say that in quotes, because you can make a case for everything, but usually we want to test, are you able to defend what you are saying? Okay, so if this was me, what I would say is we use clustered random sampling. Sorry, I mean stratified. Now the reason why I say stratified is because these are in different warehouses around the country. I assume they're made in those different um, areas around the country. So if there's a problem in the commerce manufacturing plant, then you would notice that with all the jars that are from the commerce manufacturing plant. So because they're manufactured in the same place under the same condition, you would expect that if some are underfilled, that is where they would be. So here I would say this is a case of stratified because they're manufactured in the same area. They're manufactured in the same area and they're more likely to have a similar characteristic, or they're more likely, yeah, they're more likely to have similar characteristics, whether they're underfilled and so on, because they're manufactured under the same condition in the same area. So here, I just want you guys to think about it, and then you make a case for whatever it is you believe the answer is. And then we have the non-probability sampling methods. Now, these non-probability